Today we'll discuss about register sets and port registers and pull up and pull down register concepts of MSB 430. You know already that MSB 430 contains 8 port registers starting from P1, P2 and so on up to P8. Each register can be accessible by byte, nothing but byte wise 8 registers are available, or in other terms we can call like word wise registers that are available 4, means these 4 registers merged as 4, column as PA, PB, PC and PD. So each are of 16 bit. So either byte-wise you can operate or you can operate as a word-wise. Yeah. So these 8 GPIO registers are again can be controlled by a control registers, calling it as in, out, direction, selection, resistor enable, interrupt edge select, and interrupt flag. So these are the 8 controlling registers that can control the 8 peripheral registers or port register that we just stated. Yeah. So let me go through the various controlling registers now. And these controlling registers generally can be operated on P1 and P2. Hence, here for an example, we have taken it as P1. Hence, P1 in, P1 out, and so on. Okay. So P1 in. Once a particular GPIO pin is configured as input, then P1I represents the input values. Similarly, a particular pin is configured as output, then P out is having the output values. So P1DAR is the register using which we can make a particular pin as input or output. When P1DAR equal to 0, then corresponding pin is input. When P1DAR is 1, then corresponding pin is going to be the output. And whenever you are dealing with the input pin, then some other registers also useful, just calling it as a P1REN, nothing but resistor enable, which enables pull down or pull up register, which enable pull down or pull up registers. More about it we'll see in the following slides. Next register calling it as selection. Whenever a particular pin is to be used as some peripheral register, peripheral pin, for example, a timer pin or ADC pin or some other pin, then this selection is to be configured. By default, it is going to be the GPIO. By configure it, we can make it as timer pin or any other peripheral pin. And to deal with the interrupt, we have 3 controlling registers calling it as IE, IES, and IFG. IE, interrupt enable. To make a particular interrupt from the particular peripheral is to be enabled or to be disabled, is to be executed or not to be executed, or is to be masked or not to be masked, is decided by this IE. Okay, next IES. The particular pin is to be configured on falling edge or on rising edge or on both edge, can be decided by this IES. Means at which edge the particular interrupt is to be executed is decided by this IES. IES 0 nothing but positive edge. IS1 is nothing but the negative edge. Negative edge means high to low. Positive edge means low to high. Okay. IFG. When IFG, nothing but interrupt flag register, which is used to indicate whether a particular interrupt is occurred or not, or whether interrupt is in pending or not in pending. This is decided by IFG. Yeah. And to deal with the input mode or input register, so we particularly need to have a concept calling it as pull up and pull down resistor concept. So in these 2 slides, you will let you know why these pull up and pull down resistors are useful. Yeah, if you observe this diagram, the A red colored box indicates microcontroller unit in which input is connected through VCC through R11 to ground through the button. Suppose if you imagine when there is no R1, without R1, when you use the button for providing the input, okay, when button is open, then when button is open, we don't know which input will be given to the MCU. And when button is closed, of course, the MCU gets ground value, nothing but logic zero value. But in uh, open case, when button open case, so now there is no valid input will be available for MCU. We call it as floating input. So to avoid this, when you put R1 in this manner, so when you put R1 in this manner and when button is open, then the microcontroller unit gets VCC value because of R1. In this way, R1 is useful for pulling VCC value or logic 1 value to the MCU. Hence, the R1 we call it as the pull-up resistor. So which is useful here for avoiding the floating inputs. I mean, now coming to the pull down concept. In pull down concept, when you observe here, so where R1 is going to be the pull down here. So without R1, now also if you observe, so when switch is closed, maybe VCC is applied, nothing but logic 1 is applied. When switch is closed, we can't imagine which input will be given to the MCU. We call it as again floating. To avoid this one, here we are having R1. When R1 is there and switch is open, then MCU gets ground or MCU gets logic 0. In this way, R1 is used to provide logic 0 to the MCU. And as this is pulling down to the ground value, hence this is calling it as pull down resistor. And to deal with this pull up and pull down resistor, so we are having a resistor calling it as REN. So to enable them, REN is to be used. When REN equal to 0, pull up or pull down is not enabled. When REN equal to 1, then pull up or pull down are going to be enabled. And to particularly choose either pull up or pull down, here we are going to use of out. When out equal to 1, pull up is taken. When out equal to 0, pull down is taken. Okay, that's why for configuring a particular pin as input, we not only use in and direction, we also required REN as well out. Okay, so REN is for enabling pull up or pull down, and out is for selecting pull up or pull down, DAR for making it as input, and in the particular input value to be given. And already we discussed about selection. If you observe the selection register, when selection is equal to 0, general input output will be provided to particular input. And when SCL equal to 1, then it act as the timer pin or particular peripheral pin. In this way, to select a particular peripheral pin to configure a pin as a particular peripheral pin, this ACL is going to be useful. So with this, we discussed about the pull up pull down concept, followed by peripheral registers and its controlling registers. Thank you.